Now that we've learned how to factor trinomials of the form x squared plus bx plus c, let's apply these concepts to other types of trinomials in the same form, but that could look a little bit different at first. So our first example, we notice that we have x squared minus 35 minus 2x. And what you'll see is that the terms are written out of order. They're not in descending order for the trinomial. So anytime when working with a trinomial, and your terms are not written in descending order, make sure that you rewrite them in descending order so that you can factor the trinomial. Let's go ahead and work with this one. Now that it's in descending order, we know that x times x gives us our first term, and now we think what multiplies to give us the negative 35, but adds to give us the negative 2. So it would be some combination of 7 and 5, and we would want a negative 7 and a positive 5 to meet the conditions of both the b and the c values. Now let's look at a different example. There can be times when you're working with trinomials where you're going to have more than one variable, in this case 2 variables. So we have x squared minus 8xy plus 12y squared. Let's try to factor this one, and since we already have that x squared out in front, this is in the correct order, so let's try and factor this one. We know that x times x would give us our first term of x squared. But now let's look at our last term, 12y squared. Now we want to think of the things that would multiply to give us the 12y squared, but also add up to give us that negative 8. So our possibilities for the 12y squared could be negative 3y times negative 4y, or negative 2y times negative 6y. And that is the combination that can multiply to give us our last term of 12y squared, but also help us get that negative 8 in the middle. So let's put in the minus 2y and the minus 6y. Now people often wonder at this point, how is that going to work since there's an xy in the middle? Where does the xy come from? Because there isn't any xy's that we see together on this line. Well, if we multiply this together and check our answer, we can identify where that xy comes from in our middle term. Let's do that example. Let's just check our answer quickly here. X times x gives us x squared. X times, this is our first one, here's our second one, x times negative 6y is negative 6xy. And now we're starting to see where the xy comes from. Negative 2y times x is negative 2xy. And then we multiply our last ones to give us 12y squared. And if we combine those like terms, we see where that middle term, 8xy, comes from. So we know that this combination works. And so we just had to, the only difference of what we had to do here was just add y's to those last constants that we're not used to doing to our last terms. Let's look at a few more examples here. Our next example is, what do we do if we identify trinomials that look like they're in a different form? So we always want to look for a GCF first. So if you look at our first example, we notice that there's a coefficient in front of our x squared. It's a 3 out in front, but that 3 is a common factor from all 3 terms. So let's begin by factoring out a GCF. And so you always want to factor out a GCF if one exists. We end up with 3, and in our parentheses, x squared plus 6x plus 5. And now that we've factored out the 3, we want to see if there's anything else we can do to factor this. Because our instructions are to factor it completely. We factored it partially right now, but the trinomial x squared plus 6x plus 5 can be factored further. And so let's try it. we keep our 3 out in front because that doesn't go away. And we know that x times x gives us our x squared in the trinomial. And now we look at our 5 and our 6, and we think, what would multiply to give us a 5, but add to give us a 6? And we know that the only combination would be a positive 5 and a positive 1. So here, factoring the trinomial took 2 steps. First the GCF method, and then our trinomial method. Let's do one more example of that. Number 2 looks a bit more intimidating because not only is there a coefficient in front of our first term, we also notice that we have x to the fourths and x to the third and x squared in our various terms. So let's factor our GCF out of all of these terms. Here, our greatest common factor is a 2 and an x squared, but since our first term is negative, I want to factor out a negative as well to make that first term a positive. So let's factor out a negative 2x squared as our GCF and see what our trinomial is. We end up with x to the second plus 8x minus 20. So we've factored this, and so this could be our answer unless that trinomial can be factored more. And so let's look at our trinomial of x squared plus 8x minus 20 and see if it could be factored farther. X times x could give us our first term. And then we think of what multiplies to give us negative 20. And so 4 and 5 or 10 and 2. And 10 and 2 is the likely combination. And let's just make sure we have our signs right. We would want to have a positive 10 and a negative 2 to multiply to give us a negative 20, but add to give us a positive 8. So again, factoring this trinomial took 2 steps to factor it completely. And our last example is we come back to this idea of a prime polynomial. We learned earlier that a prime polynomial is any polynomial that cannot be factored. And so let's look at some trinomials. These are both trinomials, and we're going to see if we can factor them. We know that x times x would give us x squared. And then we need to think what 2 terms could multiply to give us 5, but add to give us 4. So we could think of our only combinations for 5 are 5 and 1. And so they either need to be both positive 5 and 1 or negative 5 and negative 1. But in either combination, whether you put in positive 5 and positive 1 or negative 5 and negative 1, they can never add up to give us our middle value of positive 4. So there's no combination that could work that would, with integers, that would give us this trinomial. And so therefore, this cannot be factored. And so we would call it prime. Let's look at one more example. We try this trinomial, x and x, and then we think there are factors of negative 6. And so we could have combinations of 2 and 3, or 6 and 1. And you could change the signs, but no matter what with those 2 possibilities, you could never get them to add up to give us our middle term of negative 3. So again, this trinomial is prime. So anytime you encounter a trinomial, try all the different possibilities that could possibly work, all the factors of that final C term, and if none of them can add up to give you your B term, only then should you write that the polynomial is prime.